Hi everyone, today we're going to study RSA algorithm. Two common types of encryptions are the symmetric encryption, which uses a single key for both encryption and decryption, and the asymmetric encryption, which uses a public key for encryption and a private key for decryption. RSA is one among the first and most widely used algorithms for asymmetric encryption. This algorithm is nicknamed after its architects, Ron Rivest, Adi Shamir, and Leonard Adleman. The math behind this RSA are modular exponentiation and prime factorization of very large numbers. Here are the steps on encryption and decryption by RSA algorithm. Step 1. We first choose two primes, P equals 11 and Q equals 13. Step 2. Let n equals the product P times Q. So we have 11 times 13, and that is 143. Step 3. Let capital A equals the quantity P minus 1 times the quantity Q minus 1. So we have 11 minus 1 times 13 minus 1. So this is 10 times 12, that is 120. Step 4. Choose an integer e with this e in between 1 and capital A, such that the GCD of e and capital A equals 1. Let us choose e equals 11. Step 5. We find the decryption key, an integer d, by finding the multiplicative inverse of e mod a, that is 11 modulo 120. This can be done using the extended Euclid's algorithm, and it turns out as 11. For step 6, the public key consists of the numbers n and e, and the private key consists of the numbers n and d. The ciphertext, the formula is capital C equals capital P raised to e mod n. To recover the plain text from the ciphertext, we must do decryption. So the plain text, the formula will be capital P equals capital C raised to d mod n. Let us see this example. By RSA algorithm, encrypt the plain text, which is the number 7. Then later, decrypt it. For step 1, we write the formula for ciphertext. That is capital C equals capital P raised to e mod n. In our problem, the P here corresponds to the number 7. The n, that is the product of the two primes, 11 times 13, and that is 143. And the e, we choose to be 11. Substituting the values to this formula, we have now capital C equals 7 raised to 11 mod 143. Then step 2, translate 11 as binary. We will get the value 11 is equal to 1011 base 2. Now step 3. Express 7 raised to 11 as per binary exponents. Remember that the values 1, 0, 1, 1 corresponds to this table. The number 1 here corresponds to 8, 0 corresponds to 4, 1 corresponds to 2, and this one corresponds to 1. Which means the 7 raised to 11, we're going to express this into 7 raised to 8 times 7 squared times 7 raised to 1. Take note that the exponents are corresponding to those values here with element 1. Now for step 4, we're going to solve this corresponding moduli. 7 raised to 1 mod 143, 7 square mod 143, 7 raised to 4 mod 143, 7 raised to 8 mod 143. Let's begin with the 7 raised to 1 mod 143. This is the same with 7 mod 143, which is also equal to 7. Now for the second moduli. 7 squared becomes 49 mod 143, and we simplified this into 49. Next, 7 raised to 4 mod 143, we can express this into the quantity 7 squared times 7 squared mod 143. Remember that we have an identity like this. So we will apply this into this expression. So this is equal to 49 mod 143 times 49 mod 143, then mod 143. This 49 mod 143, we have the value from the previous step. So we can substitute 49 times 49, then mod 143. The product here will give us 2401. Then we write the mod 143. We simplified this into 113. We go now to 7 raised to 8 mod 143. We can expand this 7 raised to 8 into 7 raised to 4 times 7 raised to 4. Then we will apply our identity here. So it becomes 113 mod 143 times 113 mod 143. We can simplify this 113 mod 143 into 113 only, then times 113. Then we write mod 143. The product here will give us 12,769 mod 143. When we simplify this, we will get 42. Now let us clear our screen and let us write the corresponding values for respective modulus. So it will be like this. We proceed now to step 5. We're going to solve 7 raised to 11 mod 143 into the quantity 7 raised to 1 times 7 squared times 7 raised to 8, then mod 143. The right side becomes 7 raised to 1 mod 143 times 7 squared mod 143 times 7 raised to 8 mod 143, then mod 143. Take note that we use the identity in this step. On the next step, we're going to simplify each of the moduli. We can get the values here from step 4. So it will be 7 times 49 times 42, then mod 143. We can get the product of the three terms. So we have 14,406, then mod 143. Simplifying this now, the value will be 106. This is the final answer. Now let's go to part B of the problem. And that is, we're going to decrypt this ciphertext 106. For step 1, we're going to use the formula of plaintext. That is capital P equals capital C raised to D mod n. From the problem, we have these values. Capital C is the 106. The n is the product of 11 and 13, which is 143. And the D is the same with 11. So we write again our formula into capital P equals 106 raised to 11 mod 143. Then step 2. We write 11 as binary. We know that this value is 11 equals 1011 base 2. Then step 3, express 106 raised to 11 as per binary exponents. Remember that we have this table, and this 106 raised to 11 is equal to 106 raised to 8 times 106 squared times 106 raised to 1. Now for step 4, we're going to solve these respective moduli. 106 raised to 1 mod 143, 106 squared mod 143, 106 raised to 4 mod 143, and 106 raised to 8 mod 143. Let's begin with the first modulus. This 106 raised to 1 can be written as 106. Then mod 143. The answer is 106. The next is 106 squared mod 143. We can simplify this square into 11,236, then mod 143. We simplified this into 82. Next, 106 raised to 4 mod 143. We can express this 106 raised to 4 into 106 squared times 106 squared, then mod 143. When we apply our identity, this expression becomes like this. 106 squared mod 143 times 106 squared mod 143, then mod 143. We can get the value of this 106 squared mod 143 from the previous step. So it becomes 82 times 82, then mod 143. The product of this 82 by 82 is 6,724. Then mod 143, the value is 3. Then we go to 106 raised to 8 mod 143. We can express this into 106 raised to 4 times 106 raised to 4, then mod 143. Using our identity, we can write this into 106 raised to 4 mod 143 times 106 raised to 4 mod 143, then mod 143. The value of this 106 raised to 4 mod 143, we can get this from the previous step. That is 3. Substituting, we have now 3 times 3, then mod 143. The product here will be 9, and when we simplify this, the answer is 9. Let us clear the screen, but we will write the corresponding values of our moduli. So it will be like this. Let's go to step 5. We will solve now capital P equals 106 raised to 11 mod 143. And we will simplify this using this expression. The quantity 106 raised to 1 times 106 squared times 106 raised to 8, then mod 143. Using our identity, it will be like this. 106 raised to 1 mod 143 times 106 squared mod 143 times 106 raised to 8 mod 143, then mod 143. The values here we can collect from step 4. So the corresponding modulus are simplified into like this. 106 times 82 times 9. Then this mod 143. We can simplify by getting the product. It will be 78,228, then mod 143. We can simplify this, and the value is 7. We can see that this number 7, or the plain text, has been recovered. This is the final answer. I hope you learned something from this video. See you again next time.